Hello students, today let us start our session with the qualitative analysis of organic compounds. So the organic compound that may contain carbon and hydrogen. In addition to these two elements that may also contain the atoms like oxygen, nitrogen, sulphur, halogen or even phosphorus. So how these elements to be identified, that follow some chemical test. Let us see the detection of carbon and hydrogen for a given organic compound. That can be done by heating organic compound with copper 2 oxide. When copper 2 oxide is heated with the organic compound, the compound containing carbon, it gets oxidized to carbon dioxide and the copper 2 oxide is reduced to copper. So to identify the formation of carbon dioxide, the liberated gas is passed through lime water, where we may find the formation of the milky white turbidity that confirms the carbon dioxide is produced by heating, and this carbon dioxide formation in turn it confirms the organic compound contains carbon. And the hydrogen present in organic compound is oxidized to water and copper 2 oxide is reduced to copper metal, and the formation of water is confirmed by passing this towards over the anhydrous copper sulfate, where it turns into blue color. It confirms water is produced upon heating organic compound with copper 2 oxide. So the color change confirms that organic compound contains both carbon as well as hydrogen. To detect the presence of nitrogen or nitrogen sulfur, sulfur or halogen, we have to prepare LASSAIGNE'S extract, that is nothing but sodium fusion extract, in which the sodium metal and organic compound is taken in a fusion tube, a very small tube, and it is heated to red hotness. Then the red hotted tube is plunged into about 20 ml of water taken in a china dish, and that content is boiled for about 10 minutes. After that it gets cooled, then filtered. That filtrate is known as LASSAIGNE'S extract. So that filtrate contains what? That is nothing but, if the organic compound contains nitrogen, then the filtrate may have the sodium metal reacts with the carbon of organic compound and that of nitrogen to form sodium cyanide. So you will get sodium cyanide solution. Or if the organic compound contains only the sulphur, then the extract will contain sodium sulphide. Or if the organic compound contains carbon, nitrogen and sulphur, then the product will be sodium thiocyanate. The extract will contain sodium thiocyanate. Or if the compound contains only the halogen, then the extract will be sodium halide. Okay, what is the purpose of preparing this extract? It is due to organic compounds are covalent compounds and most of the time they will be non-polar in nature. So to make them to ionize, it gets heated with sodium metal, where the compound is converted into its ionic form. Now the taking down of reactions will be easier and the elements can be detected. So this is the reason why do we prepare LASSAIGNE'S extract. To detect the presence of nitrogen in a given organic compound, let us take that sodium fusion extract, treating with ferrous sulfate and concentrated sulfuric acid. The fusion extract that contains cyanide ion, it reacts with the ferrous ions of ferrous sulfate to form ferrocyanide. On further heating with the concentrated sulfuric acid, some of the ferrous ion is getting oxidized to ferric ion. So this formed ferrocyanide further reacts with the ferric ion and it forms a Prussian blue color. The formation of Prussian blue color, it confirms the presence of nitrogen in the given organic compound. So ferrocyanide with ferric ion, it forms ferric ferrocyanide. This is what the color of Prussian blue. When nitrogen is alone present in organic compound, we got Prussian blue color. Suppose the organic compound has both nitrogen and sulfur, then it would not give Prussian blue, instead it forms blood red color. Why? Because the extract that contains only thiocyanate. The thiocyanate on treating with the ferric ion, it forms blood red color. The formation of blood red color that confirms the organic compound contains both nitrogen and sulfur in its compound. The next one, detection of sulfur. So when organic compound contains sulfur alone, then the extract that may contain sodium plus sulfur to form sodium sulphide. This sodium sulphide, that means the extract, when it is treated with the lead acetate, it forms a black precipitate of lead sulphide. When it is treated with lead acetate, CH3COO twice Pb, and the solution is acidified with acetic acid, it forms lead sulphide and sodium acetate. So this lead sulphide is black in color, so we will get a black precipitate. If this sodium fusion extract is treated with sodium nitroprusside instead of lead acetate, we will get a violet color. So let us take the sodium sulphide, only the sulphide ion. It is treated with the nitroprusside solution FeCN 5 times NO, and whose charge is 2 minus. That makes the violet color formation of FeCN5 NOS 4 minus. This appearance of violet color, it confirms the presence of sulfur in its organic compound. So detection of halogen. The reagent is silver nitrate, which is acidified with nitric acid. So the extract, it is acidified with nitric acid followed by treating with silver nitrate. So if I have the compound of sodium chloride, that extract contains chloride, I will get AgNO3 that forms AgCl plus NaNO3. This AgCl is a white precipitate. It says a curdy white precipitate. And the formation of curdy white precipitate is further treated with the ammonia solution, where the disappearance of curdy white precipitate occurs. Disappearance of white precipitate. That seems silver chloride is soluble in ammonia. Instead chloride, if the compound contains bromide, so I can write NaBr plus AgNO3, that gives AgBr plus NaNO3. This AgBr is also a pale yellow precipitate. This is a pale yellow precipitate which is sparingly soluble in ammonium solution. Sparingly soluble in ammonia solution. Or the compound contains iodide, so the reaction will be NaI with silver nitrate. The precipitate is silver iodide and NaNO3. But the color of the silver iodide is a deep yellow precipitate, and which becomes insoluble in ammonia, solution. So the presence of halogen that can be detected by treating with silver nitrate, whose mixture is acidified with actually nitric acid. So due to the difference in the formation of colors depending upon the nature of halide present and followed by its solubility in ammonia, which halide is present in the organic compound can be detected. Detection of phosphorus. The phosphorus that cannot be detected by using sodium fusion extract. Actually the organic compound is getting converted, that containing phosphorus is treated with the sodium peroxide, an oxidizing agent, where phosphorus is converted into sodium phosphate. Sodium phosphate is Na3PO4. So this is obtained by heating organic compound with sodium peroxide that forms sodium phosphate. Later on, sodium phosphate is boiled with concentrated nitric acid that gives H3PO4, orthophosphoric acid, and sodium nitrate. So, this phosphoric acid is then treated with ammonium molybdate NH4 twice MoO4. This is ammonium molybdate in presence of nitric acid, where phosphoric acid gets converted into ammonium phosphomolybdate. The formation of ammonium phosphomolybdate is confirmed through its color change, the yellow coloration or the precipitate that confirms the compound contains phosphorus, plus NH4 NO3 plus H2O 12. This is 12 times, here 21 times, so this is 21, and the water will be 12 H2O. That's all. So after the detection of elements, we have to estimate how much percentage of each element is present in organic compound. That can be done by different methods. So that methods are known as quantitative analysis of organic compounds, by which we can able to calculate the percentage of each element present in a given organic compound. Let us take first of all the estimation of carbon and hydrogen. Both of the elements that can be detected by using a simple experiment itself, in which a known mass of organic compound, say W gram, is heated with excess of oxygen and carbon dioxide. The oxygen must be excess and carbon dioxide, where the carbon containing, that is the organic compound containing carbon, is oxidized to carbon dioxide and the hydrogen is oxidized to water. The formed carbon dioxide and the water is allowed to absorb through the U-tubes. The U-tubes contains anhydrous calcium chloride, which absorbs the moisture, that means the water, and the other U-tube that contains concentrated potassium hydroxide solution that absorbs carbon dioxide. So we have to weigh the U-tubes before and after the absorption of gases. So the difference in masses of U-tube that tells us how much of carbon dioxide and water produced during the oxidation reactions. So let us calculate the percentage of hydrogen first of all, mass of organic compound, let it be W gram, and mass of water be W 1 gram. We know the molar mass of water is 18 gram. So we can say 18 gram of water contains 2 gram of hydrogen. Therefore, W gram of water will contain how much of hydrogen? So we can write 2 by 18 into W 1 gram. W 1 gram we have to take. And the whole mass of the hydrogen is obtained from only the W gram of organic compound. So we can say, therefore, W gram of organic compound contains, W gram of organic compound contains 2 by 18 into W 1 by W gram of hydrogen. Therefore, the percentage of hydrogen is equal to 2 by 18 into W 1 by W into 100. This gives the mass percentage of hydrogen. Same way for the carbon, we say let us the weight of carbon dioxide be. So we can write mass of carbon dioxide be W2 gram. And what about its molar mass? 12 plus 32, 44. So we can say 44 gram of carbon dioxide contains 12 gram of carbon. Therefore, W2 gram of carbon dioxide will contain, therefore, W2 gram of carbon dioxide will contain 12 divided by 44 into W2 gram. The entire mass is obtained from mass of the W gram of organic compound. Therefore, the organic compound, the W gram of organic compound contains 12 divided by 44 into W2 by W. If you want to calculate the percentage, we can even multiply this is with 100. So, by this method, we can able to estimate the percentage by mass of hydrogen as well as carbon in a given organic compound. Estimation of nitrogen. So, nitrogen can be estimated by Dumas method. It is one of the method. We have one more method. So, in this Dumas method, actually the organic compound is made to heat with copper 2 oxide. On strong heating, the elements present in organic compound gets oxidized into their gaseous products, where the nitrogen is leaving behind as free nitrogen. Some traces of nitrogen oxides will also be formed, but those oxides also be converted into free nitrogen by passing that gases over the heated copper gas wire. Now, let us find how nitrogen is produced. See that I have taken the organic compound, and this organic compound is an unknown compound. I don't know how many of hydrogen, carbon or nitrogen is present in it. So, such a way I can assume the compound contains X times of carbon, Y times of hydrogen and Z times of nitrogen. So, when it is heated with copper 2 oxide, where carbon is oxidized to carbon dioxide, hydrogen is oxidized to water and nitrogen is left as free nitrogen, that is N2. Okay. Let us see how many carbon I have, X times. So, I have X times of carbon dioxide. I have Y times of hydrogen. So, I get Y times of water. And I have Z times of nitrogen. So, it is Z times of N2. Now, how much of copper 2 oxide is required? See, nitrogen I didn't consider with any of the oxide. It is a free one. But only the oxygen from copper 2 oxide is associated with carbon and hydrogen. So, here how many times I have oxygen in carbon dioxide? 2 into X times, and in water I have only Y time. But oxygen is a diatomic element. So, I can write the copper 2 oxide contains 2X plus Y by 2 of copper, and the oxygen is 2X times of oxygen from carbon dioxide. I have taken 2X, but in water it is Y times of H2O, but oxygen is a diatomic element. So, the Y is divided by its atomicity. So, the Y by 2 I have taken. So, you can balance the oxygen is present in 2X times of carbon dioxide and Y by 2 times of oxygen in water. But the copper which is left behind is 2X plus Y by 2 of times of copper we have. Okay. Now, the liberated nitrogen is to be estimated. How it is estimated? All the gases that are allowed to pass through the tube containing potassium hydroxide. The potassium hydroxide that absorbs carbon dioxide, and the nitrogen gas is allowed to collect at the top of the graduated tube. From the graduated tube, you can find what amount the volume of nitrogen is produced during the reaction. And the nitrogen gas is passing through the one, and it is associated with the water also, because the mixture it contains water. Carbon dioxide is alone absorbed by potassium hydroxide, and the aqueous form of nitrogen is present over the surface of the collected tube. Okay. From the Boyle's law, we know the relationship between pressure, volume, temperature. We will say that ideal gas equation and all. Okay, let us see. Pressure, volume by temperature equal to P1 V1 by T1. This is for two different gases. And this is to be taken for at STP condition. At STP condition, the temperature is 273 Kelvin and the pressure is 760 millimeter of mercury. So, we know the STP conditions of pressure and temperature. So, you can take what is the volume of nitrogen collected. V is equal to P1 V1 by T1 into 273 by 760. Let it be the VML of nitrogen collected. And here I have P1. P1 is the pressure due to the gas liberated. Which gas liberated? Nitrogen. Nitrogen is not at all collected in its dry form. It is along with, that is, it has water moisture also. So, that pressure of gas that is pressure of the nitrogen will be calculated by subtracting atmospheric pressure, the aqueous tension from atmospheric pressure. So, the P1 is calculated by subtracting aqueous tension from atmospheric pressure. Aqueous tension is nothing but the pressure due to the moisturized nitrogen. Now, I have the room temperature that is equal to T1 Kelvin. So, I got the values of P1, T1, everything. So, now substitute. I know 760 millimeter of mercury I have taken. When the value is 760 millimeter, then the volume of nitrogen will be 22,400 ml. 22,400 ml of nitrogen that weighs about 28 gram. Therefore, VML of nitrogen weighs, this VML of nitrogen weighs at the STP is 28, the volume of mass of nitrogen that occupies the volume of 22,400 ml into V into 100, because I am finding out its percentage divided by the mass of the organic compound. This is what the Dewey mass method in which nitrogen is estimated. The other method of estimation of nitrogen is Geldahl's method. The previous method is Dewey mass method, where the organic compound is entirely converted into its gaseous product by heating with copper 2 oxide, where we got the free nitrogen. But in this case, the nitrogen is converted into ammonia. How it is done? See that organic compound is heated with the concentrated sulfuric acid, where the nitrogen present in it is converted into ammonium sulfate. This ammonium sulfate is then treated with the excess of sodium hydroxide solution, where you are getting ammonia, sodium sulfate and water. This produced ammonia is then allowed to absorb in concentrated solution of sulfuric acid and whose concentration is known. So, that is said to be a standard sulfuric acid. So, the amount of ammonia produced in the reaction that can be determined in terms of the amount of sulfuric acid consumed in the reaction. How? See, before the reaction we know what volume of sulfuric acid is taken, and at the end of the reaction ammonia that absorbs some amount of sulfuric acid, so it will give away some amount of sulfuric acid. So, the difference of sulfuric acid what we have taken before the reaction and the amount of sulfuric acid left after the absorption of ammonia, that gives us the difference of that sulfuric acid, that volume of sulfuric acid which is left over, then it is allowed to titrate against the standard solution of sodium hydroxide. See, ammonia when it is passed over sulfuric acid, where it is converted into ammonium sulfate. Let us take the mass of organic compound be W gram, and we did the titration of the standard solution of sulfuric acid against the standard solution of sodium hydroxide, and the concentration of both sulfuric acid and sodium hydroxide is taken as same molarity. If at all sulfuric acid is 1 molar, sodium hydroxide is also 1 molar. So, the concentration of the solutions same. Let us take the polarity of sulfuric acid be M and that of volume of sulfuric acid is BML. Let us take volume of sodium hydroxide used for the titration of excess of sulfuric acid. What is excess of sulfuric acid? That is what the sulfuric acid left after the completion of reaction, that only titrated against the known volume of sodium hydroxide. It is equal to V1 ml. So, during the titration V1 ml of sodium hydroxide is consumed and the molarity of sodium hydroxide is also M. I said molar concentration of both sulfuric acid and sodium hydroxide are same. Okay. See the reaction. Actually, the reaction of sodium hydroxide with the sulfuric acid, the number of moles of sodium hydroxide required is 2. But according to volumetric analysis, V1 M1 is equal to V2 M2. So, the product of mass and volume and molarity of one of the solution should always be equal to the product of concentration and volume of the solution. But here 2 moles of sodium hydroxide required for 1 mole. Suppose if I take sodium hydroxide V1 ml, then sulfuric acid required for the titration will be the half of its volume of sodium hydroxide. So, if at all it is V1 ml, then the sulfuric acid required for the reaction is V1 by 2 ml because due to the stoichiometric relationship. So, let us say volume of unused sulfuric acid of molarity will be the total volume of sulfuric acid is V ml, by which only V1 by 2 ml of sulfuric acid is used for its titration. Therefore, volume of leftover unused sulfuric acid is V minus V1 by 2 ml. Now, this volume of sulfuric acid that absorbs ammonia. See once again, ammonia when it is absorbed in sulfuric acid, it gives ammonium sulfate. Here, how many times ammonia is consumed? 2 times of ammonia. So, the volume of leftover is V minus V1 by 2. But this volume is twice the time absorbed by ammonia. Therefore, we can say volume of V minus V1 by 2 ml of sulfuric acid of molarity is equal to twice the time of ammonia, that is twice the time the volume of sulfuric acid is absorbed. So, 2 into V minus V1 by 2 ml of ammonia of molarity m. 1 liter of ammonia solution whose concentration is 1 molar, that contains 17 gram of ammonia, or you can say 14 gram of nitrogen. This is what the standard solution of ammonia. So, 14 gram of nitrogen only being present in 1 liter of 1 molar ammonia solution. Therefore, 2 into V minus V1 by 2 ml of ammonia contains how much of nitrogen? That is the question. So, 2 into V minus V1 by 2 ml of ammonia solution of molarity m that contains 14 gram of nitrogen into its molarity into 2 into V minus V1 by 2 divided by the volume, that is equal to 1000 gram of nitrogen. From this you can estimate what is the mass percentage of nitrogen present in W gram of organic compound. So, that is equal to 14 into molarity into 2 into V minus V1 by 2 divided by 1000 into the percentage 100 divided by mass of organic compound. 100 and 1000 can be cancelled off. So, 14 by 10 it becomes equal to 1 by 4. So, the rest of the estimation of nitrogen, that is the mass percentage of nitrogen, is given by 1.4 into molarity of the solution into 2 into V minus V1 by 2 divided by mass of the organic compound. So, this is what estimation of nitrogen we did by 2 methods. One is Dumas method and other one is Geldahl's method. The next one is estimation of halogen. So, in this, the organic compound containing halogen is treated with fuming nitric acid and silver nitrate solution, and the entire mixture is taken in Carrier's tube. So, the method itself is called Carrier's method. So, in this, the compound nitric acid is a strong oxidizing agent that oxidizes the carbon and hydrogen into their carbon dioxide and water. The halogen present in organic compound that gets converted into the corresponding silver halide. So, the silver halides AgX, that AgX might be AgCl or AgBr or AgI. And we know the color of the compound also. AgCl, a curdy white precipitate will be formed, AgBr, a pale yellow precipitate, and silver iodide is a deep yellow precipitate. And we should know their molar masses of the compound also. So, I have given the data of atomic masses of the element. AgCl, you should add the atomic mass of silver with chlorine, so that it gives rise to 143.5 gram per mole. And silver bromide, we have to add 108 with 80, so we will get 188 gram per mole. And silver iodide, we should add 127 with 108, so that it gives 235. So, let us find the percentage of chlorine in W gram of organic compound. So just like hydrogen and carbon, how we have estimated, same pattern only we are going to take, only the atomic mass of the estimating element and its corresponding compound only differ. So we can write, we have silver chloride. Let us take first of all, the atomic mass of chlorine is 35.5 and that of silver chloride is 143.5. And the mass of silver chloride is W1 gram, which obtained from the W gram of organic compound, and the percentage it is multiplied with 100. Therefore, this is what percentage of chlorine in W gram of organic compound. Similarly, the percentage of bromine in W gram of organic compound. So, we can take organic bromine atomic mass 80 and the whole mass of silver bromide is 188. Let the mass of silver bromide be W1 and that of mass of organic compound is W gram and it is into its percentage. Just like we can find out the percentage of iodine in W gram of organic compound. So that gives the atomic mass of iodine is 127 and that of silver iodide is 235 into the mass of silver iodide divided by mass of organic compound into 100. So by this method we can able to estimate both silver chloride, silver bromide, silver iodide. In turn, what about their percentage of chlorine, bromine or iodine present in a given organic compound? Similarly, by the same method, we can estimate even sulphur. So, if the organic compound contains sulphur, that too is allowed to oxidize with either fuming nitric acid or sodium peroxide. The fuming nitric acid or sodium peroxide that converts carbon into carbon dioxide and hydrogen into water and sulphur into sulfuric acid. So, sulphur gets oxidized to sulfuric acid. Then this sulfuric acid is treated with excess of barium chloride solution. Excess of barium chloride solution where it is converted into a white precipitate of barium sulfate. So, in all the cases, even in the formation of halogen or even in the formation of barium sulfate, we are getting only their precipitate. So, the precipitates has to be filtered and the precipitate to be dried off and then it has to be weighed. From that weight only we are calculating how much of silver chloride or bromide or even barium sulfate. So, let us find out the percentage of sulphur in given organic compound. Therefore, percentage of sulphur in W gram of organic compound is given by the sulphur atomic mass is 32, barium sulfate the entire atomic mass that is equal to 233. Let the mass of barium sulfate be W1 gram, which is obtained from the W gram of organic compound into 100. So, this is what how the percentage of sulphur is estimated by Carrier's method. Estimation of phosphorus. Just like how we detected the phosphorus, same way the organic compound is allowed to oxidize with either fuming nitric acid or sodium peroxide, in which the phosphorus is into sodium phosphate, which is then treated with the nitric acid or boiling with the concentrated nitric acid that gives orthophosphoric acid. This orthophosphoric acid then converted into ammonium phosphomolybdate by treating with ammonium molybdate. So, we will get either yellow coloration or yellow precipitate of ammonium phosphomolybdate. So, the whole mass of ammonium phosphomolybdate is 1877 gram. The atomic masses of phosphorus, molybdenum and all given over here. So, out of 1877 gram of ammonium phosphomolybdate, the phosphorus is just present one time. So, the percentage of phosphorus in W gram of organic compound in terms of ammonium phosphomolybdate is given by 32 by 1877. 32 is nothing but the mass of phosphorus into W1 gram of ammonium phosphomolybdate by W gram of organic compound into 100. Or the compound which is formed, phosphoric acid, is treated with the magnesium mixture. The magnesium mixture is nothing but the mixture of magnesium chloride, ammonium chloride and ammonia, where the phosphoric acid is converted into magnesium ammonium phosphate. Later on strong heating, it decomposes to magnesium pyrophosphate. The molar mass of magnesium pyrophosphate is 322 gram, but that compound contains 2 phosphorus atoms. So in this case, the mass of phosphorus is 32, but in magnesium pyrophosphate, the phosphorus is twice the time present. So the atomic mass of phosphorus to be taken as 64. Therefore, the percentage of phosphorus in W gram of organic compound in terms of magnesium pyrophosphate, we get 64 by 322 into W1 is the mass of magnesium pyrophosphate and W is the mass of organic compound into 100. Estimation of oxygen. Actually, once we estimated all the elements present in hydrocarbon or the compounds of estimation of oxygen. Once all other elements estimated in a given organic compound, the sum of their percentage mass when it is subtracted from 100, we can get the percentage of oxygen. This is one way. The other way is the given organic compound is heated in a stream of nitrogen, where all the elements present in it gets oxidized into their oxygen and all other gaseous products. Then the mixture of gases is passed over red hot coke, where carbon that converts oxygen into carbon monoxide. Later on, the carbon monoxide is treated with iodine pentoxide, where the carbon monoxide is converted into carbon dioxide and iodine. So, in terms of either the liberated mass of oxygen or the liberated mass of carbon dioxide, we can estimate what is the amount of oxygen present in it. Let us take the estimation of oxygen in terms of carbon dioxide. Carbon dioxide mass is 44, in which oxygen is present 32 gram. Therefore, we can write the percentage of oxygen in W gram of organic compound is 32 by 44 into the mass of carbon dioxide produced and the mass of organic compound into 100. Okay students, we have completed successfully the one chapter from organic chemistry. Hoping you understood all the concepts whatever delivered. Okay, let us see the next session with the next new chapter and with new topics. Until then, bye bye.